Regarding wall-mounted light fixtures, luminaires within 5 feet horizontally and less than 12 feet vertically from the water surface must be GFCI protected. Luminaires cannot be located within 7.5 feet above the water level unless they meet specific conditions. Firstly, surface-mounted or recessed. Secondly, have a glass or plastic lens or globe. Thirdly, non-metallic or electrically isolated metal body or trim. And fourthly, be suitable for damp locations. The village electrical inspector has not yet inspected the fixtures, so it's unclear if they meet these specific conditions. The electrician who called may be concerned because the fixtures have metal trim. However, if the trim is electrically isolated, they may be acceptable. Skylights that are within 7.5 feet above the water level must also meet the conditions listed above. The specific type of skylights are unknown, so it's unclear if they meet these criteria. To determine if a fixture has electrically isolated trim, look for a notation on the fixture or packaging indicating that it has electrically isolated trim or isolated metal parts. Consult with the manufacturer or electrician for further clarification. Contact the village electrical inspector upon their return to clarify the requirements. Discuss these issues with the electrician who installed the fixtures. If necessary, obtain written confirmation from the electrician that the fixtures meet the requirements. Consider hiring a qualified electrician who specializes in electrical safety to inspect the fixtures and installation. Article 680(42) of the National Electrical Code, or NEC, covers spas and hot tubs. It provides specific requirements for the installation of electrical equipment in and around these areas to ensure safety. The key areas covered in Article 680(42) include firstly, GFCI protection. All 125-volt, 15 and 20 amp receptacles located within 10 feet of the inside walls of a spa or hot tub must be protected by a ground fault circuit interrupter, or GFCI. This is to prevent electric shock hazards. Secondly, lighting fixtures and ceiling fans. Lighting fixtures and ceiling fans installed within 12 feet horizontally and less than 7.5 feet vertically from the water's surface must be GFCI protected. There are also restrictions on the types of fixtures allowed within certain distances. Thirdly, switches. Switches must be located at least 5 feet horizontally from the inside walls of the spa or hot tub. Fourthly, underwater luminaires. Underwater luminaires must be specifically approved for use in spas and hot tubs and must be installed in accordance with their listing instructions. They typically operate at low voltage, often 12 volts alternating current. Fifthly, bonding. All metal parts of the spa or hot tub structure, including metal fittings, reinforcing metal in the concrete shell, and metal equipment enclosures, must be bonded together and connected to a grounding electrode. This helps to equalize the electrical potential and reduce the risk of shock. Sixthly, wiring methods. Wiring methods used in and around spas and hot tubs must be suitable for wet locations and installed in accordance with the NEC. Typically, this means using rigid metal conduit, intermediate metal conduit, or non-metallic conduit. Seventhly, clearance. Sufficient clearance must be maintained around electrical equipment to allow for safe access and maintenance. Eighthly, equipotential bonding. This involves creating a bonding grid around the spa or hot tub to equalize the voltage potential in the area. This is especially important in areas with concrete or other conductive surfaces. Ninthly, outdoor installations. For outdoor installations, additional requirements may apply, such as protection against physical damage and weather exposure. It is important to consult the latest edition of the NEC and local codes for specific requirements in your area. Also, it is advisable to hire a qualified electrician experienced in spa and hot tub installations to ensure compliance with all applicable codes and regulations. Electrically isolated trim refers to a design feature in electrical fixtures where the metal trim is intentionally separated from the electrical circuit to prevent electrical shock hazards. This is particularly important in wet or damp locations, such as bathrooms or near hot tubs, where the risk of electric shock is higher. Here's a more detailed explanation. The purpose of electrically isolated trim is to ensure that the metal trim, which might be touched by someone, is not energized even if there is a fault in the fixture's wiring. This significantly reduces the risk of electric shock. Key features of electrically isolated trim include firstly, non-conductive materials. A non-conductive material, such as plastic or a specialized insulating compound, is used to create a barrier between the metal trim and the electrical components of the fixture. This barrier prevents any electrical current from reaching the trim. Secondly, insulated connections. Any screws, clips, or other fasteners used to attach the trim to the fixture are also made of or coated with non-conductive materials to maintain the electrical isolation. Thirdly, grounding. While the trim itself is isolated, the electrical components of the fixture are properly grounded according to electrical codes. This ensures that any fault current is safely directed to ground, tripping the circuit breaker or GFCI. Fourthly, testing and certification. Fixtures with electrically isolated trim are typically tested and certified by recognized testing laboratories such as UL, Underwriters Laboratories, or ETL in Turtic, to ensure they meet specific safety standards. These standards often include requirements for electrical isolation, insulation resistance, and grounding. How to identify electrically isolated trim? Firstly, look for markings. The fixture or its packaging may be marked with terms like electrically isolated trim, or insulated trim. Secondly, check specifications. Review the product specifications or documentation provided by the manufacturer. These documents often include detailed information about the fixture's construction and safety features. Thirdly, inspect the fixture. Carefully examine the fixture for any visible non-conductive barriers between the metal trim and the electrical components. Look for plastic or other insulating materials that separate the trim from the wiring and internal parts. Fourthly, consult the manufacturer. If you are unsure whether a fixture has electrically isolated trim, contact the manufacturer or a qualified electrician for assistance. They can provide additional information and help you verify the fixture's safety features. Compliance with electrical codes. The use of electrically isolated trim is often required by electrical codes in wet or damp locations to enhance safety. For example, the National Electrical Code, or NEC, may specify requirements for fixtures installed near spas, hot tubs, and swimming pools. Benefits of using electrically isolated trim. Firstly, enhanced safety. Electrically isolated trim significantly reduces the risk of electric shock, protecting users from potential hazards. Secondly, code compliance. Using fixtures with electrically isolated trim helps ensure compliance with electrical codes and regulations, avoiding potential violations and penalties. Thirdly, peace of mind. Knowing that your fixtures have electrically isolated trim provides peace of mind, especially in areas where water and electricity are in close proximity. In summary, electrically isolated trim is a crucial safety feature in electrical fixtures designed for wet or damp locations. It provides an additional layer of protection against electric shock by ensuring that the metal trim is not energized even if there is a fault in the fixture's wiring. Always look for fixtures that are clearly marked as having electrically isolated trim and consult with a qualified electrician to ensure proper installation and compliance with electrical codes. Article 680 of the National Electrical Code, or NEC, specifically addresses the requirements for electrical installations in and around swimming pools, spas, hot tubs, and similar water features. It aims to minimize the risk of electrical shock and ensure the safety of people using these facilities. Article 680 is divided into several parts, each covering different aspects of electrical safety around water. Here's an overview of the key sections and requirements. Part 1 General. This section provides general requirements that apply to all electrical installations covered by Article 680. It includes definitions, bonding requirements, and general wiring methods. Definitions. Clarifies the meaning of terms such as swimming pool, spa, hot tub, and fountain, which are essential for understanding the scope of Article 680. Bonding. Requires the bonding of all metal parts of the pool, spa, or hot tub structure, including metal fittings, reinforcing steel in the concrete, and metal equipment enclosures. Bonding connects these metal parts to create an equipotential plane, reducing the risk of voltage differences and electric shock. Wiring methods. Specifies acceptable wiring methods for use in and around pools and spas, such as rigid metal conduit, intermediate metal conduit, or non-metallic conduit. Part 2. Permanently installed pools. This section covers the specific requirements for permanently installed swimming pools. Receptacles. Requires ground fault circuit interrupter, or GFCI, protection for all 125-volt receptacles located within a certain distance of the pool. Typically, this distance is 10 feet from the inside walls of the pool. Lighting. Restricts the placement of lighting fixtures near the pool. Lighting fixtures must be located at least 12 feet above the maximum water level or be ground fault circuit interrupter, or GFCI, protected if they are closer. Underwater lighting. Specifies requirements for underwater lighting fixtures, including the use of low voltage fixtures, proper grounding, and bonding. Electrical equipment. Covers the installation of electrical equipment associated with the pool, such as pumps, filters, and heaters. This equipment must be properly grounded and protected from the weather. Part 3. Spas and hot tubs. This section addresses the specific requirements for spas and hot tubs, which may differ slightly from those for swimming pools. GFCI protection. Requires ground fault circuit interrupter, or GFCI, protection for all electrical equipment associated with the spa or hot tub, including receptacles, lighting, and equipment. Receptacle placement. Restricts the placement of receptacles near the spa or hot tub. Receptacles must be located at least 5 feet from the inside walls of the spa or hot tub. Lighting and ceiling fans. Specifies requirements for lighting fixtures and ceiling fans installed near the spa or hot tub. These must be located at least 12 feet horizontally and less than 7.5 feet vertically from the water's surface and be ground fault circuit interrupter, or GFCI, protected. Bonding. Requires the bonding of all metal parts of the spa or hot tub structure, similar to the requirements for swimming pools. Part 4. Fountains. This section covers the electrical requirements for fountains. GFCI protection. Requires ground fault circuit interrupter, or GFCI, protection for all electrical equipment associated with the fountain, including pumps, lighting, and receptacles. Wiring methods. Specifies acceptable wiring methods for use in and around fountains, similar to the requirements for swimming pools and spas. Submersible pumps. Addresses the requirements for submersible pumps used in fountains, including proper grounding and bonding. Part 5. Permanently installed therapeutic tubs. This section covers therapeutic tubs that are permanently installed. GFCI protection. Requires ground fault circuit interrupter, or GFCI, protection for all electrical equipment associated with the therapeutic tub. Receptacle placement. Restricts the placement of receptacles near the therapeutic tub, similar to the requirements for spas and hot tubs. Bonding. Requires the bonding of all metal parts of the therapeutic tub structure. Part 6. Hydromassage bathtubs. This section covers hydromassage bathtubs, which are typically installed indoors. GFCI protection. Requires ground fault circuit interrupter, or GFCI, protection for the circuit supplying the hydromassage bathtub. Receptacle placement. Restricts the placement of receptacles near the hydromassage bathtub. These must be located at least 3 feet from the inside walls of the tub. Additional considerations. Local codes and regulations. Always check with local authorities for any additional requirements or amendments to the NEC. Inspections. Ensure that all electrical work is inspected by a qualified electrical inspector to verify compliance with the NEC and local codes. Qualified electrician. Hire a qualified electrician experienced in pool, spa, and hot tub installations to ensure that the electrical work is done safely and correctly. Regular maintenance. Perform regular maintenance on electrical equipment to ensure it is in good working condition and free from hazards. Article 680 is a critical reference for anyone involved in the design, installation, or maintenance of electrical systems around water features. By following the requirements outlined in this article, you can significantly reduce the risk of electrical shock and ensure the safety of people using these facilities. A ground fault circuit interrupter, or GFCI, is a safety device designed to protect people from electric shock. It works by monitoring the electrical current flowing in a circuit and quickly interrupting the power if it detects a ground fault. Here's a more detailed explanation of how a ground fault circuit interrupter, or GFCI, works and its key features. Basic principle. A ground fault circuit interrupter, or GFCI, compares the amount of current flowing into a device in the hot wire with the amount of current returning from the device on the neutral wire. Under normal conditions, these two currents should be equal. If there is a difference, it indicates that some of the current is leaking to ground, which could be through a person touching a live wire or a faulty appliance. How it works. Firstly, current monitoring. A ground fault circuit interrupter, or GFCI, contains a sensing coil that monitors the current flowing through the hot and neutral wires. Secondly, differential current detection. If the difference between the incoming and outgoing current exceeds a certain threshold, typically 5 mA, 0.5 amps, the ground fault circuit interrupter, or GFCI, detects a ground fault. Thirdly, rapid interruption. Upon detecting a ground fault, the ground fault circuit interrupter, or GFCI, quickly trips a switch that cuts off the power to the circuit. This interruption occurs within a fraction of a second, typically 20 to 30 milliseconds, which is fast enough to prevent serious injury or death. Fourthly, reset mechanism. After tripping, the ground fault circuit interrupter, or GFCI, must be manually reset by pressing a reset button on the device. This ensures that the fault is corrected before power is restored to the circuit. Key features of GFCIs. Sensitivity. Ground fault circuit interrupters, or GFCIs, are highly sensitive to ground faults and can detect very small differences in current. Speed. Ground fault circuit interrupters, or GFCIs, react very quickly to interrupt the power supply, minimizing the duration of the electric shock. Protection. Ground fault circuit interrupters, or GFCIs, protect against electric shock hazards caused by ground faults, which can occur due to faulty wiring, damaged appliances, or contact with water. Testing. Ground fault circuit interrupters, or GFCIs, have a test button that allows you to verify that the device is working correctly. It is recommended to test ground fault circuit interrupters, or GFCIs, monthly to ensure they are functioning properly. Types of ground fault circuit interrupters, or GFCIs. Receptacle ground fault circuit interrupters, or GFCIs. These are installed in place of standard electrical receptacles and provide ground fault circuit interrupter, or GFCI, protection at that location. They are commonly used in bathrooms, kitchens, garages, and outdoor areas. Circuit breaker ground fault circuit interrupters, or GFCIs. These are installed in the electrical panel and provide ground fault circuit interrupter, or GFCI, protection for an entire circuit. They are often used for circuits that supply power to multiple outlets or devices in a specific area. Portable ground fault circuit interrupters, or GFCIs. These are portable devices that can be plugged into a standard outlet to provide ground fault circuit interrupter, or GFCI, protection for temporary applications such as construction sites or outdoor events. Common applications of ground fault circuit interrupters, or GFCIs. Bathrooms. Ground fault circuit interrupters, or GFCIs, are required in bathrooms to protect against electric shock hazards near sinks, showers, and bathtubs. Kitchens. Ground fault circuit interrupters, or GFCIs, are required in kitchens to protect against electric shock hazards near sinks and countertops. Outdoor areas. Ground fault circuit interrupters, or GFCIs, are required in outdoor areas to protect against electric shock hazards from wet conditions and contact with the ground. Garages. Ground fault circuit interrupters, or GFCIs, are required in garages to protect against electric shock hazards from power tools and equipment. Swimming pools and spas. Ground fault circuit interrupters, or GFCIs, are required near swimming pools and spas to protect against electric shock hazards from water and electrical equipment. Compliance with electrical codes. The use of ground fault circuit interrupters, or GFCIs, is mandated by electrical codes in many locations to ensure safety. For example, the National Electrical Code, or NEC, specifies where ground fault circuit interrupters, or GFCIs, are required in residential and commercial buildings. In summary, a ground fault circuit interrupter, or GFCI, is a critical safety device that protects people from electric shock by detecting ground faults and quickly interrupting the power supply. They are widely used in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Always ensure that ground fault circuit interrupters, or GFCIs, are installed and functioning properly to provide maximum protection against electrical hazards. The 5 mA trip threshold is a critical specification for ground fault circuit interrupters, or GFCIs. It refers to the maximum amount of leakage current that a ground fault circuit interrupter, or GFCI, is allowed to detect before it trips and cuts off the power to the circuit. Here's a detailed explanation of why this threshold is important and how it relates to electrical safety. Understanding the 5 mA trip threshold. A milliampere, or mA, is 1/1000th of an ampere. Therefore, 5 mA is equal to 0.5 amperes. This small amount of current is significant because it represents the level at which electricity can become hazardous to humans. Leakage current. In electrical circuits, a small amount of current can sometimes leak to ground due to insulation breakdown, moisture, or other factors. This leakage current is typically harmless under normal conditions. However, if a person comes into contact with a live wire and provides a path to ground, even a small leakage current can cause an electric shock. Ground fault circuit interrupter, or GFCI, operation. A ground fault circuit interrupter, or GFCI, continuously monitors the current flowing through the hot and neutral wires of a circuit. Under normal conditions, the current flowing into a device on the hot wire should be equal to the current returning from the device on the neutral wire. If there is a difference of 5 mA or more, the ground fault circuit interrupter, or GFCI, detects a ground fault and quickly trips to cut off the power. Safety implications. The 5 mA trip threshold is designed to protect people from electric shock by interrupting the power supply before the leakage current reaches a level that could cause serious injury or death. Studies have shown that currents above 10 mA can cause muscle contractions, difficulty breathing, and even ventricular fibrillation, a life-threatening heart rhythm. By tripping at 5 mA, the ground fault circuit interrupter, or GFCI, provides a significant margin of safety. Compliance with standards. The 5 mA trip threshold is mandated by safety standards and electrical codes around the world. For example, the Underwriters Laboratories, or ALL, standard for ground fault circuit interrupters, or GFCIs, requires that they trip when the leakage current exceeds 5 mA. Similarly, the National Electrical Code, or NEC, requires the use of ground fault circuit interrupters, or GFCIs, in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Testing and certification. Ground fault circuit interrupters, or GFCIs, are rigorously tested and certified to ensure that they meet the 5 mA trip threshold. These tests include subjecting the ground fault circuit interrupter, or GFCI, to various fault conditions and verifying that it trips within the specified time and current limits. Regular testing. It is recommended to test ground fault circuit interrupters, or GFCIs, monthly to ensure that they are functioning properly. The test button on the ground fault circuit interrupter, or GFCI, simulates a ground fault and verifies that the device trips as expected. If the ground fault circuit interrupter, or GFCI, fails to trip during the test, it should be replaced immediately. Advantages of the 5 mA trip threshold. Sensitive protection. The 5 mA trip threshold provides sensitive protection against electric shock, minimizing the risk of injury or death. Fast response. The ground fault circuit interrupter, or GFCI, trips very quickly, typically within 20 to 30 milliseconds, to cut off the power supply. Wide applicability. The 5 mA trip threshold is suitable for a wide range of applications, including residential, commercial, and industrial settings. In summary, the 5 mA trip threshold is a critical specification for ground fault circuit interrupters, or GFCIs, that ensures they provide effective protection against electric shock. By tripping at 5 mA, the ground fault circuit interrupter, or GFCI, interrupts the power supply before the leakage current reaches a level that could cause serious injury or death. Always ensure that ground fault circuit interrupters, or GFCIs, are installed and functioning properly to provide maximum protection against electrical hazards. The phrase wet location refers to an environment where exposure to water or other liquids is frequent or prolonged. In electrical terms, it is a classification used to determine the types of equipment and wiring methods that are suitable for use in such conditions. Understanding what constitutes a wet location is crucial for ensuring electrical safety in compliance with codes and standards. Definition of wet location. The National Electrical Code, or NEC, defines a wet location as an area where the following conditions exist. Firstly, subject to saturation with water or other liquids, such as washdown areas or locations exposed to weather. Secondly, unprotected locations exposed to weather. Thirdly, interior installations subject to splash, spillage, or submersion. Examples of wet locations. Outdoor areas. Locations exposed to rain, snow, ice, and direct sunlight, such as open porches, decks, and rooftops. Underground locations. Manholes, tunnels, and direct burial installations where equipment is subject to continuous or intermittent contact with water. Car washes. Areas where equipment is directly sprayed with water and cleaning solutions. Industrial facilities. Processing plants, breweries, and food processing areas where equipment is frequently washed down. Agricultural buildings. Areas where livestock are housed and equipment is exposed to moisture and waste. Indoor areas. Bathrooms, showers, and laundry rooms where equipment may be splashed or sprayed with water. Requirements for electrical equipment in wet locations. Equipment suitable for wet locations must be designed and constructed to prevent water from entering and causing damage or creating an electrical hazard. Key requirements include waterproof enclosures. Equipment enclosures must be designed to prevent water from entering. These enclosures are typically made of corrosion-resistant materials such as stainless steel, aluminum, or non-metallic materials. Wiring methods. Wiring methods used in wet locations must be suitable for the environment. This typically means using waterproof conduit, such as rigid metal conduit, intermediate metal conduit, or non-metallic conduit, and fittings that are designed to prevent water from entering. Grounding. Proper grounding is essential in wet locations to ensure that any fault current is safely directed to ground. This helps to prevent electric shock hazards. Identification. Equipment suitable for wet locations is typically marked with the letters wet location or with a symbol indicating its suitability for use in wet environments. Compliance with standards. Equipment used in wet locations must comply with relevant safety standards such as those published by Underwriters Laboratories or other recognized testing laboratories. These standards specify requirements for water resistance, corrosion resistance, and electrical safety. Common types of equipment used in wet locations. Lighting fixtures. Lighting fixtures designed for wet locations are typically enclosed in waterproof housings and use gaskets to seal out moisture. Receptacles and switches. Receptacles and switches used in wet locations are typically enclosed in waterproof boxes and use weatherproof covers to protect against moisture. Motors and pumps. Motors and pumps used in wet locations are typically designed with sealed bearings and waterproof enclosures to prevent water from entering. Cables and connectors. Cables and connectors used in wet locations are typically designed with waterproof jackets and seals to prevent moisture from entering. Importance of using equipment suitable for wet locations. Safety. Using equipment suitable for wet locations helps to prevent electric shock hazards and ensures the safety of people working or living in these environments. Reliability. Equipment designed for wet locations is more durable and reliable than standard equipment, as it is built to withstand the harsh conditions associated with exposure to water and moisture. Compliance. Using equipment suitable for wet locations helps to ensure compliance with electrical codes and standards, avoiding potential fines and penalties. In summary, a wet location is an environment where exposure to water or other liquids is frequent or prolonged. Electrical equipment used in wet locations must be designed and constructed to prevent water from entering and causing damage or creating an electrical hazard. Always use equipment that is specifically marked and certified for use in wet locations to ensure safety and compliance with electrical codes.